Hey guys, good evening to everyone who has joined us today. I'm Spoorthi from 6th semester ECE. Today I'll be introducing you to machine learning and data handling. First, let's go through today's agenda. We'll start off by going through the basic definition of machine learning and where it stands with respect to AI and deep learning. Then we will go through the life cycle of an ML project and understand the various steps that's involved in an ML project. Later, we'll be going through an example to understand data handling, data visualization, and model building. Artificial intelligence is like a broad classification of programs that are given the ability to learn and reason like us humans. Machine learning is like a subset of AI and it deals with algorithms that have the ability to learn without being explicitly programmed. Deep learning is a subset of machine learning and it consists of artificial neural networks that adapt and learn from huge amount of data. Coming to the classification of machine learning algorithms, it is broadly classified into three groups. In supervised learning, we provide both inputs and corresponding outputs to our machine. Basically, here we work on labeled data. Say you have a data set containing images of mangoes and strawberries, and these images are marked as mangoes or strawberries. So when we feed this data to a model, it will learn how to differentiate between them. So if we give an image of a mango, it should be able to return mango as the output. Supervised learning can be further classified into regression or classification. It's called regression when the output depends on real values, and it's called classification when the output is various categories. Few examples of regression models are weather forecasting, market forecasting, whereas classification could be image classification or diagnostics. Coming to unsupervised learning, we provide only the inputs with no corresponding outputs. The computer will understand and make sense of the given data. Say we're providing the system with unlabeled images of vehicles. The system will cluster them based on similar features and give us the output. And few examples of unsupervised learning are recommender system, targeted marketing, structured discovery, etc. Coming to reinforcement learning, it's basically a trial and error learning where the machine learns from the consequences of its action. It is a reward penalty type of learning, and it's similar to the way we train our pets, where we give out like a treat for every desired action. It is used in robotics for industrial automation. Now let's look at the life cycle of an ML project. We start off by understanding the problem statement and identify what actions that need to be performed in order to solve that particular problem. Then we collect the required data for the project. Then we pre-process the data. This is like one of the most important steps in any machine learning project. And today we'll be focusing on this uh, part of project in our workshop. Here we first analyze the data and find out things such as shape and number of features. Then we visualize the data so that we get an idea of the trends in our data. Then we sometimes add new features or delete certain features, and this falls under feature engineering. Now that we've pre-processed the data, we'll have to build a model. We can either directly import models or code one of our own. But today we'll be importing the logistic regression model. Coming to model training, it's here that our model learns the logic and it's trained to predict the output. Then we evaluate how well our model is trained. And if we are not satisfied with the result, then we go back and build a different model and repeat these two steps again. Finally, we provide our trained model with some sort of new data to see if it's working or not. So, yeah, let's start off with the workshop. So before we start off, I would like you guys to go to the Drive link that's provided in the description. You'll be directed to the following page where you'll have to download the .csv file. Just right click and click on download, and that's about it. So once you have done that, for people who are not using Jupyter Notebook, you can, don't worry, you can use Google Colab. So let's go to Google and type Google Colab and click on the first link that pops up. So here you will be asked to sign in. Once you've signed in, you will have to go to File and create a new notebook. Once you have done that, you will end up with a page something like this where you can like rename your file. I'll probably give you like a minute to do this. So the libraries that we'll be using today are NumPy, Pandas, Seaborn, and Matplotlib. NumPy will help us to work with multidimensional arrays and matrices and also provides a large collection of mathematical functions to operate upon. Pandas helps us in data manipulation and analysis. Seaborn helps us in data visualization. Matplotlib also provides us with functions for data visualization, but it's very basic compared to Seaborn. So today we'll mostly be using Seaborn, but don't worry, throughout the workshop, I'll be providing you with various links where you can learn all these various libraries and their functions. So I hope you guys have done this. So let's start off by importing the required libraries. Let's import NumPy as NP. We will need pandas and we'll import it as PD. Then we'll need Seaborn and we'll import it as SNS. Finally, we will need a matplotlib dot plot and we'll import it as PLT. So once you've typed this, in order to execute this code cell, you can either do that by clicking this play button over here or just pressing Shift and Enter. Once you've successfully imported your required libraries, we'll have to upload the .csv file that we've downloaded. So for that, we'll import another library from google.colab, import files, and we'll be using files.load function. Once you've typed it, run the cell. So you should get this option where you can choose the files, right? So let's go ahead and choose our file and go to downloads. And I have the Titanic.csv. Let's just open it. Once it's done completely, we'll start off by reading our data frame. So first, we will create a variable df, which will be our data frame. We'll be using pandas, and we've imported it as PD. So PD, and we have a function called read underscore CSV. And this will basically help us read the CSV file. And inside this, in double quotes, we will have to type the CSV file's name. For those of you who are using Jupyter, this will be the path to the file's location. And over here in Colab, if you click on files, should be able to see this titanic.csv being uploaded. Okay. Now let's just run the cell. So now we have successfully imported our data frame. If we were to display the first few rows of our data frame, we have a function called head. So if we say df.head, by default, it displays the first 5 rows of our data frame. But if we wanted to display like the first 10 or first 20 rows of our data frame, we just have to give the value 20 in the brackets and run the cell again. So here we have the first 20 values. So what if we want to read the last 20 values, right? So all that you have to do is change the head to tail. So this is like the last 20 values of our data set. And let's take another case where we have to read 100 to 130th row, and we need only the following columns from survived to age, right? So all that we have a function called log for it. So you have to call it like df.log by brackets. We need the rows 100 to 130, and we need the columns survive to age. Okay. If you're getting some sort of error, it might be due to this. It's case sensitive, so make sure that your column name matches whatever arguments you're giving here. So now we have extracted 100 to the 30th row, and we're displaying survived T class, name, gender, and age columns. Okay. Let us look at the shape of our data frame. What basically this gives us is the number of rows and columns in our data frame. This is like a very useful information, and if we were to inspect our data frame, we can give df.info, enter, and here you will see all the columns and the data types and the number of non-null values. And if you want to like see the number of null values in each column, we do df.sna. This returns true for every null value in your data frame. And we basically are gonna sum them up to display the sum. So here we can observe that the age column has 177 null values, cabin has 687 null values, and embarked has 2 null values. Okay, so if you want to display like a particular row in your data frame, say you want to display the ticket column, then yeah, all you have to do is type df quotes, single quotes, and the column name. And also, guys, if you're having a hard time following, don't worry. I'll be sharing this book, this notebook in the same link as the same drive link. So yeah, so now if we want to extract all the rows of people who survived the crash, then we'll say df of survived. Or one more thing about this data is that for every person who survived the crash, survived is marked as 1. And for people who did not survive the crash, it is marked as 0. Okay. So if we were to survive, extract all the people's data who survived the crash, then the survived value will be 1. So this will mark all the rows from df where survived is 1 as true. And this will display their data like this. Can even give dot head. It's 5 values. Okay. So say you want to display all the survived passengers details, but their gender should be male. So you do and a different condition. So that will be df of gender will be equal to say male. Okay. So if we run this, we get like the information of all the male passengers. If you want to store this as a different data frame, you can do so by saying x is equal to, and your x will be the new data frame. But we will not be doing that right now. Suppose you want to, extract only survived and gender columns from this data frame that you've extracted. All you have to do is treat it like a two-dimensional array and give a list of columns that you would want to extract. Say we want to extract survive, and okay, I'll not be extracting gender, I'll be extracting their names. So I hit shift enter. This is what we get. Cool. Now let's create some new features and add it to our data frame. As we can see here, we have like ton of null values which has to be taken care of. So let's start off with age, and we'll be replacing the null values in age with the mean value of age column. Okay, so we'll create a new variable called mean, and we need to calculate the mean age, right? So df.age, the column dot mean. This will return the mean value. And if you want to see mean, what the mean value is, you can see that it's about 29.6. Okay, so we'll be replacing the current age column with the new age column, and we'll do so by filling it with NA, and we'll be replacing the null values with the mean value. So dot fill NA basically fills the null values in the rows with the mean age value. So once we run the cell, and if we hit df.info, and see that age has 891 non-null values as compared to 714 non-null values. So that means that we've basically filled all the null values with the mean value of age. Now we can observe that embarked has a data type of object. So what happens is that you can't give an object type to your model by training it. So we'll have to encode it. So let's first look at the unique values that are present in the embarked column. Oops, unique. So this will give us this will give an array of all the unique values present in that particular column. So you can see there are a few null values, which we'll take care of that later. So first we will create a dictionary called ENC1, and this will contain, we will assign an integer value to each one of these embarked values, okay, embarked unique values. So let's say S can be 1, C can be 2, and Q can be 3. Okay. It doesn't matter what value you give to these variables, because at the end of the day, your model will still perform the same way. Okay. So you can basically assign it random integers like 10, 11, 12, etc. So if we say now we'll have to encode it with these values, right? So we'll have to replace the previously existing embarked column with the new embarked embarked column, which is encoded. And the way we encode is by using map function and enc, by sending enc1 to it. So what this map function does is it iterates through all the rows, and when it finds S in the embarked column, it will replace it with the integer value 1. So, and so on. So let's run this. Also, if we have null values that we need to take care of, let's just fill those null values with 0 like we did before. So where like before we filled with mean value, here we'll be filling it with zeros. So again, the new embarked column will be to the updated embarked, and we are filling it 0. So all the null values will be now replaced with 0, the integer value 0. So if we say df dot info, now we can observe that the embarked data type has changed to float, and we have filled in all the null values successfully. Now we have cabin left to encode. So let me just print here values. So if we observe here, the first string value of cabin gives us the cabin or floor number, or the deck name, you may call it. So we'll have to basically extract only this first value of the string and not the room numbers, because that's not useful to us in any way. So the way we'll be extracting that is we'll be creating the new cabin, which is going to replace the previous cabin. And this cabin will have the previous cabin's value, but we'll be taking only the first string value, okay? So we'll be extracting only this, say here C and here E, like that. So once we do this, df dot head, you can now see that the previous values are replaced with just the alphabets of the deck. Yeah, so now we'll have to encode it, right? So we'll follow the same step. That's df of cabin dot unique will give us the unique debt names. So we have a lot of null values to fill. We'll take care of that later. So we'll copy this down, and we need a new encoding dictionary. So let's assign 1 to C, 2 to E, 3 to G, 4 to D, 5 to A, 6 to B, 7 to F, and 8 to D. After this, we will be encoding it, okay? So df of cabin will be equal to df of cabin dot map enc3. So once we've done that, we'll have to fill in the null values, right? So again, we'll be filling the null values with 0. Okay, so we've successfully done that. So if we want to analyze our data frame again, do .info. Yeah, so cabin is changed to float type, and we had to like assign the previous cabin column. We had to replace it with the new cabin column, which was filled with null values. So if you may observe, even though I filled it with NA, it didn't show any changes over here because I didn't assign the previous cabin column to it. So let's go ahead and do that. Once you've done that, you can observe that we don't have any null values left in our data frame, and we are basically encoded all of our columns that we need to train the data. So yeah, let's now visualize our data. Okay, so first let's analyze our correlation matrix. Okay. So this is a correlation matrix for our data frame, and we will plot it using heat maps to analyze it. We'll be using Seaborn library for it. So let's say SNS was, this is how we imported Seaborn. So let's say SNS dot heat map of. So the first parameter will be the correlation matrix that we want to plot. Okay. And we'll have to say if we want the annotations or not. So if we give true, it will basically display the correlation values over the heat map. And let's give a line width. This is completely optional. And let's say 0.3. So as we can see here, our heat map is very clumsy, and it's like it doesn't look good, right? So we'll be using the plot function, like a figure function from matplotlib. Okay. So here we'll be defining the figure size. I'll be giving 10 cross 10. Once we do this, so now it's easier for us to analyze it. Here we can observe that the high survivability rate, right? It depends on all these other columns like passenger ID, P class, age, parts, fare, etc. Okay. So what a heat map does is it essentially gives us the dependency of various columns with respect to each other. Since our target today is to predict whether the passenger survived the crash or not, we will have to look at the survived columns correlation with various other columns. You may notice few negative values here, right? This only means that there's an inverse relation. So if we look at whose columns, uh, okay, wait. Okay, let's just create another column first because that way it will be easier for us to analyze the heat map. Mm. So I will be defining a function called who, okay, who underscore call. This will take in a list, and the first value of the list will be the age, and the second value will be the gender. Okay. Now, what we're basically doing here is we're classifying the passengers based on their age. If the passenger's age is under 16 years of age, we'll be returning child. So if age is less than 16, then return child. Okay. Else, if gender equals to male, return man. Put this in quotes. Else, we would want to return woman. So why are we doing this, right? Oh, okay, sorry. So why are we doing this? We know that when Titanic crashed, the women and children were given the first preference to board the lifeboats. To analyze that, we're creating this new column here called who. So if you're creating a new column, all we have to do is define the new column, and I'm calling it who. This will be equal to df of age, gender. These are the columns that we're gonna send to this who underscore column function. So put this in a list, okay, because we're sending it as a list. And after that, we will have to use a function called dot apply. This will basically apply these parameters to the function who underscore column. And let's set the axis as 1. So this axis 1 just means that we're sending columns, okay? So what this does is it iterates through every row, takes in the value, for each row it takes the value of the age and gender, G capital, and it will send it as arguments to who underscore column. And from there, we will get our result, can be child, man or woman, and it will be assigned to the new column who. Okay, so let's just display data frame after doing this. Okay. So now we have a new column called who, man, which has man, woman, etc. Let's see if we have any children there. Okay, so we found a child there. Okay, and the child's age is 2. Okay, so now we'll have to encode these who values because we'll be sending it to our model, and as you know, we can't use the object values, right? So let's repeat the same steps. We have 3 values that we don't know. So let's say NC of 4 will be a dictionary, and man and be assigned value of 1. Woman can be assigned a value of 2, and child child can be assigned a value of 3. And we're going to replace the existing who with the encoded who map function. Sending in ENC4. Let's explain again. df dot head of 10. Yeah, so we have encoded the values. So male is represented with 1, woman with 2, and a child is represented with 3. So we had to do this before so that we could analyze the trends with respect to our data. Okay, but it's okay. So now if we plot our heat map again, so we can observe the relation between who and survived. Okay, look at the correlation. It's really high. It's about 0.4, right? So yeah, and this is again directly related to the assumption that we made, wherein women and children were allowed to board the lifeboats before men, right? So after heat map, let's try factor plot. So SNS dot factor plot. We'll be plotting P class. This will be our x-axis and versus survive. This will be our y-axis, and the data we'll be using is EF. And Q will be a column who. Okay. Here we can observe the high survivability rate of first class men, women, and children. So, however, more number of children from second class survived. This could have been because there were like more number of people under the age of 16 from second class. But there's no way for us to prove that right now. So let's just look at another plot of SNS of Seaborn, which is the bar plot. And here we'll be plotting cabin versus survive. Okay. And we'll be sending in our DF data frame. Here we can observe the survival rate with respect to various cabins. So I've shown you like 3 of the different plots that you can use from Seaborn. You can check out more about this Seaborn from this website, DataCamp. I think we have linked it below in the description. And it basically provides you with useful tutorials on Seaborn. And also for Matplotlib, there's V3 School. And it's really detailed and easy to follow. So you can go through that. So now, in order to be able to feed our data frame to a model, we will have to drop all the columns that are of the type object, right? In our case, let's see what those columns are. So in our case, it will be passenger ID, even though it's integer type, but it will not, affect the survived value in any way. And we saw that with our heat map here because the correlation value is really low, right? So we'll be dropping passenger ID, name, gender, and ticket. Gender because we've already encoded it as a new column called who. So we'll be creating a list of all these columns. The list will have passenger ID and name gender and ticket. So these will be the columns that we're going to drop today. So let's create a new data frame called df2, and this will contain the dropped columns. So let's just drop the columns. For that, we'll be using the function called drop, and all you have to do is send the drop list. And yeah, the access again should be equal to 1 because we're sending the column names here. Once we've done that, let's see what our new data frame holds. We have 2, right. After dropping 4 columns, we are left with only these many columns. And yeah. Now let's create 2 variables called x and y. So x will be all the columns except survived column, and these are the features that we will be using to train our model. So let's say df2.drop, and we'll be dropping only the survived column. Again, access should be equal to 1. And y will contain only the survived column. So let's say df2.drop. Again, like any changes that you make here will not be reflected in your df2 data frame. You're just creating a new variable which is going to hold these columns and their values. Oh, sorry, it's not wrong. You just need the survived column here, right? So, okay. If you want to see what these holds, do df.head. You have all the columns except for survived. And if we do y.head, we'll have the survived column here. Okay, so let's now try and train our logistic regression model. For that, we'll be importing sklearn.model selection, and we'll be importing train_test_split from it. This helps us in splitting our data into training and testing data. So let's create 4 new variables: x_train, x_test, y_train, and y_test. Okay. So we'll be using the function that we've imported, train_test_split, and to this we'll have to pass the x variable that we created here, the y variable, because we basically need to split these 2 variables, and then let's keep 70% of the data for training and the rest 30% for testing. Okay, so for that we'll have to define a test size. This will be 30%, and in terms of decimals, that will be equal to 30 by 100. That's 0.3. Okay. So after this, we'll have to import the logistic regression model. To do that, let's say from sklearn.linear model, it's one of the linear models, import logistic regression. All right. Once we do that, we'll have to create an object of this type. So let's call it LR, and this will be equal to logistic regression. Okay. So once we do that, we'll have to fit our Y train and X train. So these will be our training data sets, and Y will be our training target variable. And whereas X test and Y test, we will be using it later to test our trained model. So in order to train our model, we'll say LR be equal to the previous LR object, and we're going to fit it with X underscore train and Y underscore train. Here we're training a model. Once we've done that, we should see something like this. Once we finish that, we'll have to evaluate our trained model, right? For that, we will have to import the following sklearn metrics. So let's go ahead and import those from sklearn dot metrics. Import. We'll need accuracy score, precision score, recall score, and F1 score. So what are these different scores, right? Accuracy score tells us how many of the predicted labels are exactly the same as the expected labels. Okay, so and precision score tells us the basically shows us the ability of classifier to not label something that is false as true. Okay, and recall score tells us the ability of classifier, that is our model, to find all the positive samples. And coming to F1 score, it's just the weighted average of precision score and recall score. Okay. So once we import this, let's create various variables for each score. Let's call accuracy score as ACC, which will be equal to accuracy score. And we'll have to evaluate it on Y train. First, we'll be evaluating it on our training data set and later on our testing data set. Okay. Before this, let me just show you what happens when you try to predict the values. Okay. So when you give LR dot predict, let's say X underscore train, and run this, you'll get an array, okay, of various of the, these are the Y values that you've gotten from the trained model, okay. So if we were to compare this with our actual Y underscore train values, let's print like the first 5 values. This. So here, if you compare the two, we got the first one right. The second one isn't right. The third one is right. Fourth one isn't. And so on, right? So you can see how inaccurate our model is, right from the start. So the precision will be around 50%. So if we have to measure it, we'll have to create various variables and call accuracy score, and we'll be sending in Y underscore train here. And to this, we'll be sending the predicted Y value from X underscore. Yeah. You know what? Let's just assign a variable for this too. So let's call it pred equals the predicted values. We'll have to run the cell again. Okay. Then, yeah, so we can directly send X instead of typing it again and again. So after this, let's assign PS, the precision score. Oops. And we'll send by underscore train and X to this. Same goes for recall score and F1 score. We'll be sending y underscore train X, and finally F1 score will be F1 underscore score y underscore train comma X. Okay. X is not defined. Oh, okay, sorry, I called it bread. It's okay. Let's just call this X. Run this again. And if we run this cell again, now we've successfully calculated the various scores. Let's go ahead and print them. Let's print accuracy score. Let's do ACC, and then let's just put comma precision score equals yes, and then recall score equals recall, and F1 score okay, sorry. Let's just separate this by commas. So here you can see them in terms of decimals. So if you want to view them as percentage, just multiply each variable with 100. Okay. So you can observe that our F1 score is about 73%, recall is about 69%, precision is about 77%, and accuracy is about 80.25%. But like we've only tested it with our training data, right? But actually we'll have to test it with the test data to see how good our model is, right? So we can just copy this, Control E, and we'll have to change X value from predicting it with the training data to test data, and your accuracy score will be with respect to Y test. So we'll have to change that everywhere. Test. Now let's go ahead and print these values with respect to the test data. So yeah, here also we're getting like pretty good values, 82.08 accuracy, 78% precision, 72% recall, and 75% F1. These are pretty good scores, but you can also try various other models, okay? And you can change the parameters, and you can tune the parameters, and get better results. Due to time constraint, we cannot look into all these different models. But however, you can go through the resources available at the tutorials point. Yeah, tutorials point. This is a complete scikit tutorial, and here you have various models such as gradient descent, k nearest neighbors, decision trees, etc. You can learn all about models from here. So that's it, guys, for today. I hope you guys got to learn something new. And I also hope seeing you guys participate in the datathon. So thank you. Ciao.